again. All right, so here's a few news articles. There's a website called Have I Been Pwned that records all the stolen credentials that have been dumped public, and this guy somehow picks up people that have been phished and will tell you got phished and they got your password. So I guess it's looking at some kind of public dump, but you sign up for this and they will then email you if anybody at your company got phished, which I'd like to see. I did something like this a while ago in an unofficial way, and it's better if somebody official does it. Yeah.
So I can't go into specifics, but this actually happened today.
Yeah.
The head of security.
Yeah.
Had at the telegraph company had his password sent to the entire department thanks to the service.
They send your password.
Well, to the security.
But they're supposed to just say a password of 9 letters got stolen. They send the.
I think they have a better service.
I would question the better part of it. Actually sending your password out to you is like,
well,
that's.
It's public at that point. When it's breached and it's out there.
Okay, well,
I
guess, okay.
And
yeah.
so today we have to deal with the head of security.
Yeah.
Having their passwords.
Well, that's pretty entertaining. Yeah. If it was me, I would redesign that a little. Anyway, that seems like a poor customer experience. But anyway, this is out there. Another similar thing you can do easily by yourself is canary tokens. We do it in some of my classes. Canary tokens will make these email addresses and URLs that you put in your database on your website somewhere, and you don't use them, but they watch. And if anybody uses them, then they warn you, somebody stole your data, and they're going through it. It's a very good idea. And anyway, it's a good idea to have some kind of warning when people hack you. And so this is very interesting. It's all over the news, Saudi Arabia hacking people. The Jeff Bezos thing is very strange. Jeff Bezos has some very secondary, unconvincing argument that he got hacked by the Crown Prince of Saudi Arabia, but they didn't find the malware, and they didn't find the command and control center, and they did not observe the data leaving the phone going to that destination. They just tried to infer that it had been hacked from a total amount of data leaving. And then the Wall Street Journal said this is all garbage. It wasn't Saudi Arabia at all. It was his new girlfriend giving the pictures to her brother to sell them to the National Enquirer as part of some kind of scam, probably to make him lose his wife or something. So anyway, there's two completely different stories, both of which claim they have proof. Anyway, but it certainly is true that Saudi Arabia do hack people, just like most governments. And this is another journalist, like Khashoggi, the guy that got killed, but he's in America and Saudi Arabia hacked him. And it's interesting to hear they do what many countries do. They buy commercial government surveillance malware from Israel, typically. They bought Israeli malware, which governments buy and reuse. And by the way, our government does too. And then they hack people. This is like a bunch of people were mad last week because a Chinese national came to America, posted insulting things on the social networks in America, and when they went back to China, they jailed him for breaking Chinese law. And everyone says, those rotten bums, and my Chinese student said, I think quite correctly, well, you have to obey Chinese law. If you're a Chinese citizen, if you're an American and you violated American law, you'd be punished. It's not entirely clear that this is a huge outrage. They do have a different set of laws, and they don't have free speech there. And you can, but anyway, so it's interesting to read. This guy gets Arabic text messages and a link that tried to send him to this Arab news website, but that's a fake, well-known command and control center for this commercial espionage malware, which people use. And the Guardian and other investigative journalist types have been talking about how journalists are targeted all over the world by oppressive regimes for this. If you criticize Putin or something or any of these oppressive regimes, they will infect your phone and steal your stuff. By the way, Facebook does the same thing. Mark Zuckerberg did this. He announced it openly. When Facebook was relatively new, anybody would write a bad article about Facebook, he would steal their password and log into their account to see what they're writing and mess with them, because anybody with a popular website can steal anybody's password. You just configure the website to reject your password the first 2 or 3 times. And until people learn to use password managers, they just memorize 3 or 4 passwords. So they'll try the password, and when it doesn't work, they'll try their other password and their other password, and you just log them, and now you have everybody's password. And Zuckerberg openly admitted that he did this to journalists and got in their stuff and was never punished for it. But anyway, and by the way, the US is doing it to everybody, but we keep it secret a little bit better, except when the Russians dump it all out publicly every few years. But the NSA is hacking everybody, but they don't get caught quite as often. Anyway, so Sudo has a buffer overflow. This is pretty entertaining. So a simple stack-based buffer overflow in Sudo. So you can take over the box. This sounds awesome. I haven't found a way to set up a proof of concept. I'd like to set this up and add it to some of my projects. Sudo is pretty good, clean fun. but apparently only if you configured sudo in an unusual way. I might go back to this one. I wasted my time trying to do the email one, which is pretty much hopeless. I don't know. I didn't get into the details. Somewhere in sudo. Sudo is the command you use on Linux to escalate yourself to root. It's the equivalent of run as administrator on Linux. So everybody uses it all the time. It's an essential part of the Linux security model. And if it's got a bug, that's pretty rude. So two satellites may crash into each other tonight. There are like 10,000 satellites. There's no traffic control. It's all full of junk. It's really, really annoying astronomers. There's so much junk you can't see the stars. And there's so much junk you can't launch any more satellites without hitting the junk that's already up there. So now they're talking about setting up a satellite with like a net to like clean up the junk. So anyway, if these two crash, it'll make another pile of junk. And, you know, people are trying to come up with a plan, like zapping the junk with lasers to vaporize it, or sending up some kind of flycatcher drone to sweep it up. But the junk is becoming a problem. This guy has an argument that Android phones are perfectly fine. Don't worry, go ahead and use them for banking. Everything's all fine. And I think, as we'll see in this course, I have a different opinion. I think you see these now and then. I put this up. He strongly claims everything's fine with Android. Google put in security. Everything's fine. There's nothing to see here. And I'm not convinced. But however, it is true that Android is safer than it used to be. And if you really have the most expensive, newest phone, it's not bad. But the problem is most people's phones are years out of date, which is really bad. Anyway, WordPress is extremely insecure in practice because it has a library of plugins that are written by amateurs, and a bunch of them are vulnerable, or for that matter, malware. And so if you are careful and you only put on a few good plugins, you can make WordPress pretty secure. But if you're sloppy and you keep putting in whatever's fashionable, pretty soon you've got a mess. So 200,000 WordPresses have a plugin, and this plugin has cross-site request forgery, which is good, clean fun. This one I might set up for the 129S class. This sounds like fun. What you do is there's a proof of this video is pretty good fun. I don't think I'll play it here. I'll play it next time. But you can post a message, and when the administrator clicks on it, it takes administrative action without them knowing. That's the standard kind of cross-site request forgery. Anyway, so they're grounding the drone fleet over cybersecurity concerns, which is kind of strange to me. But they say that American drones are so advanced that our enemies will steal them to steal the technology, and they're not going to ground them until they have come up with some way to fix that, which I'm guessing would be the auto-destruct feature like Star Trek. I don't quite know what you would do. Fireworks. Yeah. Anyway, so they're closing that. And this UN got hacked, and they covered it up. Apparently, the UN is under no legal obligation to admit they got hacked, but it did eventually leak, and now everyone's saying, you rotten bum, you should have told people. And they say, we don't have to. And they say, well, you should have anyway. So anyway, their domain controllers got hacked, and they dumped out their secrets, and now everyone is all mad. The cover-up is usually worse than the offense. And Google paid a ton of money in bug bounties. No, I didn't get any of them, but you guys could anyway. But you got to be pretty hot to get these. But they paid $6.5 million out last year. So Google is really very generous at bug bounties. So is Microsoft these days. So is the Department of Defense. It's really all the rage. The San Francisco Public Works Director has been arrested and charged with fraud. I think I saw this guy running for office. Apparently, his partner is another guy who has already been convicted of fraud before. You know, as we know, the city government is incredibly corrupt here. It's world famous for this, for like Chicago in the old days, and certainly it's abundantly clear that the campus administration is absolutely as corrupt as the rest of the government. You know, it's that's the main problem here, is the fantastic amount of corruption. Our school district is famous in the state as the most corrupt, where the money just vanishes and nothing gets done to a very high extent. This tends to be the way government goes.
Chancellors get convicted, right?
Oh yeah, they convicted the chancellor who did good for the college. The guy who's actually robbing us blind gets away with it. That's usually how it goes. The chancellor that fled 7 felony convictions was actually great. He was pretty cool. He didn't put the money in his pocket. He did illegal things to get money for the college. So the college ran pretty well, but eventually they busted him and gave him the heave-ho. Then they had like 5 more people pushed out in the dark of night with flashing of blades. And now we got the latest guy, so which everybody's madder than anything. He's cutting everything except doubling his own salary. Anyway, so this is the one I spent several hours trying to set up. OpenSMTPD. This is good, clean fun. It is an email relay. It is advertised as the easiest to set up, and it was designed for BSD, which is widely considered the most secure version of Unix. and it turned out to have a simple command injection vulnerability. When you send an email, if you use the from address as an invalid domain and an invalid username, it flags the domain but not the username, and it tries to use the invalid username, and you can just inject packets in the username. So here, if you take the from address just like this with sleep in the middle of it, you can put a Unix command in the middle, it will execute. So I thought that was awesome, but the only version I could get running on my server was the wrong version, and it wouldn't compile from source. And I wasn't willing to stand up a BSD box just for this. But that's good, clean fun. And it turns out that you have to be pretty creative because you only have a total of 64 characters in an email address. So it's not really enough to put in much. So he has some clever tricks of like jumping to further code later, or how to make longer exploits in. But it's simple command injection of the type a lot of my projects are. Anyway, so let me get on to the official stuff here. And people have been suffering with the project. So let me explain what's going on. The projects are pretty tough in this course. So we're here. And the problem is the multiple operating systems. Years ago, I'd tell people you just have to have Linux or a Mac, and you can't even do it on Windows at all. And now it's not quite impossible to do it on Windows. It's just almost impossible. And this cloud version turned out to be a whole lot less useful than you might think, because they just lowered the free trial from 1,000 minutes down to 60 minutes, which is really not long enough. So students, so I was amazed they gave us so much for free, and apparently so were they. So. And there are some other free cloud services, but they're really, really miserable and don't work very well. So you might have to get a local emulator working, and that's pretty hard. Anyway, the one thing that a lot of students have hit is if you try to do it on Windows, you try to connect your Kali virtual machine to your Android emulator. Your Kali virtual machine must be on VMware, not VirtualBox. So go down, that's why I put this up, do 108 first. Do 108 first and get Kali running in VMware Player on Windows. You must have one on VMware and the other on VirtualBox, and this is because the Android emulators are running modified versions of VirtualBox, and they messed up the networking. Now, VirtualBox networking is pretty horrible anyway, and after they mess it up even more, it's essentially impossible to get a Genymotion emulator to talk to any other VirtualBox device on the same machine. You have to get to talk to a VMware machine or to another physical Windows machine. With two physical Windows machines, you can do stuff. But to get two VirtualBox devices on the same host to talk to each other is essentially impossible if one of them is an Android emulator. Anyway, so it is possible to get these things working, and I'll talk about the fun once you get it all set up a little later. So dig through these, and I had to take down a project. A student pointed out to me, one of these I just took down. Yeah, well, 403. The Bank of America finally updated their stuff. I told them like 5 or 6 years ago to update their stuff. Now they finally updated it, so they fixed this project, so it doesn't work anymore. So we'll pick on somebody else. Progressive, however, they're still the same garbage they've been for years. So we can totally hack Progressive. But the Bank of America, they even sent their security officer to go yell at me years ago at a conference, stop bad-mouthing the Bank of America. I said, well, you got to fix it? He said, no. I said, well, then we got a problem. But they finally fixed it. They finally caught up with the NFL. Now it won't run these old broken versions without forcing you to update them. So they caught up to what the NFL did 8 years ago, which is, I thought they should have done that. I sent them notes about it long ago. So apparently somebody finally got through to them. I do have the old app, but you can't use it. That was the point. I archived the old app, but if you try to run it, it won't even connect anymore. It just says you have to update the app, which is what it should have said all along. They never should have let us do this. And finally, somebody persuaded them. It's like water eroding through stone. I yell at them, other people yell at them, I mock them, I kick them to DEF CON. At some point, the humiliation builds up to where they actually fix something. It took 3 years to convince Microsoft to fix something. Yeah. What does it say? Well, I tried going tabbing at the beginning to the command line and saying ED. Well, you have to show it to me. If I see the real error message, I might be able to help you. Maybe you can show me in class or something. I have to pretty much see the error. Are you on Windows or Mac? I have a MacBook, but I'm running Linux. Oh, if you're running Linux, oh, well, gee, it should work pretty well on Linux. VirtualBox, yeah, that's actually pretty rude. This stuff usually works pretty well on Linux. But anyway, if you set it up, I can take a look at it. And yeah, but Linux Mint, boy, I would have thought that would work pretty well. Yeah, but there's always something. Anyway, all right. So I'll help people with projects later. Let me just start with the official chapter, and then I want to demonstrate the code modification project. That's my plan. You don't have too much of the chapter to talk about, and then I'll demonstrate the progressive code modification because that's kind of the punchline. You have to do about 4 projects to get everything set up. And once you got it set up, then you can totally hack progressive, which I tried right before class. It still works just like it did years ago when I wrote that project. They have not been humiliated enough to update their stuff, although the Bank of America has. So it's our job to humiliate them more, and we'll do that tonight. So, all right, so this is going to be the Android security model, the second bit of this chapter 6. So here's the game. We're going to talk about code signing, which is pretty strange, and permissions, the sandbox, and encryption. These are the basic security features, which articles like that article I pointed out at the start of class say, all these features do make Android sound pretty secure, but the apps are garbage, which kind of undoes it all. Anyway, so the plan here is your apps should each run in a different process with a different identity, and they should have their own area to store data. So no app should be able to get at another app's data, which is a pretty good idea. But the reason why everything is so dangerous is because Android is open source, like Linux. They really want to make it so everybody can get at the code and modify it, and everybody can make their own version of it for free, and everybody can write apps without having to pay anything or sign up for an official certificate or anything. And that means it's full of malware because there's no guardian anywhere. That is their fundamental philosophy, though. Like Linux, they want everything to be open and free. And the end result was Google proved experimentally that if you try hard enough, you can make Linux such a disaster that it's almost as bad as Windows. And Windows, as of about 4 years ago, there were 100 million Windows pieces of malware, 1 million Android malwares, and 100 Mac malwares. So anyway, Android, you do have to run antivirus on your Android or be careful what apps you put on. A lot of the apps in the store are malicious. Anyway, so code signing is what you've got. Code signing signs your app with a code signing key, which is public key cryptography. You've got a private key. You sign it, and you can generate the key. All the keys are self-signed, so they are not signed by any third parties. You do not need to pay a fee or register with the third party, and the signature does not prove anything about who you are. Someone else can make another signature with the same name and address in it, and there's no way anybody can tell which one's the genuine one. So that we're going to do it. We'll do it tonight. The only point of the signature is that if you update an app, it requires that the new software has the same signature as the old software. So you cannot make a modified version of an app and get people to update to your modified version. Only the original developer could do that. That's all it proves. So you have to do a little social engineering. You have to get them to uninstall the old app and install yours, and then you can totally put on a fake app, which is what we're going to do tonight. So I unpacked the Bank of America here. You just use APK tool and D to decompile it, and that will unzip it and reduce it back to Smalley, which is not exactly equal to Java source code, but it's very close to just Java source code. There's a certificate in there which shows who owns it, and it's here in the meta-inf folder. You can see the certificate. It says Bank of America and a date and some fingerprints and stuff, but I can just make my own and put Bank of America on it. There's absolutely nothing to stop me. It's not like an HTTPS certificate that's really issued by a certificate authority that actually made sure it was really the Bank of America, and if somebody else tries to get one, they won't let me get it because they'll figure out I'm not the Bank of America most of the time. Yeah.
Where it says public key algorithm.
Yeah.
1020, is 2048 still strong, or is
no? That's a very good point. This is a kind of old algorithm that is not really considered all that safe either. And by the way, that's kind of inevitable because Android keys are recommended to have a duration of 25 years, which is far longer than any of these algorithms will really be secure. So the whole thing is very different as a threat model than HTTPS certificates, which have a duration of only 3 or 4 years, and they keep having to extend the key. Now they're recommending 4096-bit keys. Not that you can easily forge these, but it's moderate, but it's not as impossible as it should be. So the whole key signing system is much weaker than HTTPS in many ways. But I do not know any attacks where you actually forge a certificate. Turns out you don't have to most of the time. Anyway, so, all right, here's another printout of it with all sorts of things, the public key and the dates and so on. And notice the expiration date is 2035. That is the official Android documentation. Make your certificate good for 25 years because you might want to put out updates for all that time. And if your certificate expired, then nobody can update their app anymore because it's impossible for you to have the same signature work. So that's why they say your signature should be good for 25 years, which of course It's a very strange decision. It's a very different security model than HTTPS certificates, although it uses the same mathematical underpinning. All right, and there's the certificates in there, usual stuff. So like I say, MD5 collisions are pretty easy to generate. Now there's been a few SHA-1 collisions generated, and last month there was another improved way to make SHA-1 collisions. So, you know, the kind of certificates used to sign Android apps are a little bit out of date and not considered very secure, but it's not like you can easily make a complete forgery, but probably sometime within that 25 years, that will become possible. Anyway, it turns out that even though you can in principle generate two files with the same SHA-1 hash, that is a much easier problem than actually generating one to match a certificate somebody else made. That is not yet possible with any reasonable amount of computer time. So it's not as bad as you might think, but still, it's you could argue that they should be using SHA-256 and 4096-bit keys and all that jazz. All right, Android doesn't verify the certificate. It does the certificate authority. It just verifies that the code matches the signature, which means it hasn't been altered since the developer put it there. By the way, it only checks it when the app is installed. If the app is somehow modified later, it will not pick that up. All right, like I say, 25 years we've talked about. All right, there have been quite a few signing vulnerabilities where you are able to use the wrong signature in Android. The master key vulnerability was in 2013 by Blue Box Security that makes one of the free Android antivirus products that's considered quite good, I think. And they find that if you put two files in the same archive with the same file name, it only checks the first file's hash. This is a very common type of problem. This applied to many, many products. It comes from writing code where it goes several times through the file, looks for something, then it checks and finds something that says, is it signed? Okay, the signature check is done. It doesn't notice there's a second file there, and the signature for that one never got checked. This happens pretty often. So anyway, there are ways to, this lets you do arbitrary code execution. You can put a completely unsigned product there, and it will treat it as if it was signed. That was, of course, fixed a while ago, and so unless your phone is really badly out of date, this particular one won't apply to you. There was an extra field length in there, the 16-bit value, but Java treats it as signed, so you can make it negative, and that means you can, again, inject altered files that aren't picked up. These kind of things keep happening. There was a name where the field length was not checked, so again, you can inject code in the file name and pass signature validation. So I remember I went to a B-Sides about 6 years ago, and the guy said, here's how you modify signed Windows binary. And I'm like, wait a minute. You can't modify signed Windows binaries. And yes, you can. There's about 8 sections of code, and it only signs 2 or 3 of the sections, and you just put code in the other sections, and it never notices. All these defenses are a whole lot less safe than you might think they are. Anyway, so you got to get into the details. And in the details, there are usually little holes you can drive a truck through. So then there's permissions. When you install an app, it'll pop up this box and say, this one needs your camera and your contacts and your Wi-Fi. And the idea is that you should notice, wait a minute, you know, why does this thing need to know my location? It's going to report my location to everybody, and there's no good reason. And you can put, by the way, third-party apps on that will let you line out and veto this stuff. But normally, you just take it all and on you go. By the way, there's a bunch of vulnerabilities that let you take permissions that don't appear in this list. That keeps happening. So even if you do pay attention, you can deceive people with this list, but they fix those when they catch them. So this is the AndroidManifest file. That's what determines it. So this is permission internet, permission Wi-Fi, permission course location, find location, camera. That's where it is. In this manifest file are all the permissions that app will request when you install it. You can define a new permission. Now, those are the built-in permissions like camera and Wi-Fi, but you could define a new permission. And if you do, you describe what protection level to give it. Now, Skype did this. Skype had a thing that was a Skype call. That was not really a phone call. It was another kind of call, not exactly a web page, not exactly a phone call. So they defined a new thing called C2D message, the ability to send a Skype message. So when they do it, they define its protection level. And in this case, the protection level is signature, which is pretty good. That means only apps with an official signature from Skype can use this permission. That would kind of make sense. Nobody except Skype should be sending Skype calls. That sounds like a pretty good idea. So normal is the default value. Dangerous is a higher risk permission that limits it. And there are other permissions out there. A signature means only things signed by the same developer that defined the permission can use it, and that's often a pretty good idea. And then there's signature or system, which means that only things signed by the developer or Google system products can use it. Those are all pretty good choices. Anyway, that's the game. All right. So signature protection is the one that's recommended. That way, nobody should use that permission except your app. However, there are fun vulnerabilities. And one thing you can do is just ask for permissions. You can make an app that just asks for all these permissions. Users don't even look at that. They just click OK. So that's simple social engineering. Or you can use a jailbreak to get root and then give yourself permissions you shouldn't have. All right. And then there's the application sandbox. Each app runs with its own permission. So here I'm running Coinbase and Schwab, and Coinbase is running as user 145 and Schwab is running as user 149. So it's installed, a new user account is created for every new app you put on, and it runs under that user account, and it has a separate data directory owned by just that person. So you see, read, write, execute for the owner, but the people in the same group and others have no permission, and so only Coinbase can get in that folder. No other user is allowed in. It's enforced the same way permissions between different users are in a multi-user Linux system. So if you can escalate to root, you can totally go in somebody else's account, but if you don't escalate to root, then Coinbase can only get in the Coinbase data folder and nobody else can get in there. That is what's called the sandbox. All right. So, by the way, the Schwab app has execute permission for everybody. So for some reason, they're putting executables inside the Schwab folder, and they expect other apps other than Schwab to be executing stuff in there, which is kind of interesting. And it might be fun to go in there and see what they're doing. I haven't checked, but that might be okay. They might have some public thing to pop up an ad or something that they want everyone to use, but it is a little unusual. Coinbase does not do that. By the way, I was doing news with Liz and Irvin this morning, and Liz found an article. Some guy lost Canadian hackers stole $50 million in cryptocurrency by doing SIM swapping on people's phones. And so a bunch of Americans are putting $1 million in Bitcoin on their phone. Don't do that. Are you out of your mind? That stuff is like cash. That should be in that should be in a USB stick in a safe deposit box. If I wrote a wallet app, I would pop up warning messages as soon as you have more than $10,000 in the wallet on your phone and say, wait a minute, this is not a safe place to store this kind of money. You should move this off your phone. So I don't know how many of you have this problem, but don't put $1 million in Bitcoin on your phone. Anyway, yeah. Well, I guess, I don't know. Anyway, I just thought I'd mention that. And now I'm probably going to have to redo the share because I hit that irritating, what's that?
50 million?
Yeah. So let's see, I got to start the share again. This irritating cable is in the way. There's always something. All right. So let me know online if you guys cannot see the share. There's no chat coming in, so hopefully they can still see the share. Anyway, all right. So there's that. And why is this not getting big? Okay, now it's getting, no, it's not getting big. Get big, I say. There we are. All right, so you don't have a separate virtual machine for each app. It's just a separate process. And the only thing protecting you is Linux user and group permissions. So that's a thing to know. Now, file system encryption is a real sore point. Ever since the iPhone 3S, every iPhone has been properly encrypted. And the way you do it is the encryption has to be turned on before you ever start using it. So everything you type in from the very beginning is encrypted. That's what you must do. If you turn on encryption later, some of the data is on there unencrypted, and there is no way to clean the data off any of these devices. It's the nature of SSDs, and by the way, hard drives now, that they store data, and you can never really get at it to thoroughly erase it because it has bad sectors that are silently replaced by replacement sectors, and some of the data is still in the bad sectors, and you can never overwrite them. So the only way to protect your privacy is to have encryption from the very start. And when you go into the settings and say, reset my iPhone to factory default, it deletes the key. All the old data is there, but nobody has the key anymore. That is incredibly effective. A few years ago, a forensic company bought 100 used iPhones on eBay, and they tried to recover data. They were not able to recover any usable data from any of them. iPhones are really safe. Now, Androids could be safe, but the problem is Androids, because they're an open ecosystem, developers write horrible apps. I've sent vulnerability reports to some of them. There are some apps that just run constantly and drain your battery. They're supposed to do things to preserve power, but Google has no ability to enforce that. So a bunch of apps waste your power so that we're always running out of power. So people are not willing to invest the power into having encryption on by default. So most Android devices do not have encryption on by default. And therefore most users don't turn it on. And that means that there's no way to ever get your personal data really off it. And it means that if I can steal your phone or put a malicious app on it, I can steal that data in principle. And so storing data on the phone is a really bad idea. So that's the game. Full disk encryption has been available for a long time in Android, but for most models, it's not on by default. And for it to protect you, it really has to be on by default before you start using the phone, the way Apple is. That is the way to do it. Anyway. By the way, the encryption they're using is a fine time. Everybody pretty much, unless you're a complete idiot, use like AES with cyberblock chaining. There is a perfectly fine encryption technique that's fast and cheap and effective. And so the quality of the encryption itself is fine, and it should be. I mean, you have to be nuts to use stupid encryption. There's perfectly fine, well-known public encryption with nice algorithms for it. And they're using the right algorithm. It's just that it's not turned on. All right. And this is a problem, of course. In 2017, Elcomsoft said only 13% of Android devices were encrypted. And here's the problem, is fragmentation. This is different versions of Android. And the basic thing we talked about before, something like 80% of all Android devices are 1 or 2 years out of date, using several versions back. So even when they add new features, most users don't get them. Only the people with the newest, more expensive phones have them. The people with older or cheaper phones are running older versions of Android. All right, by the way, the SD card is not encrypted. If you have one, that is a terrible place to put secrets. The vulnerability scanner Nessus made an Android app early on, and they stored your password in plain text on the SD card. And when people found out, they were so humiliated, they took it down and never put it up again. Because it's really bad when a professional security product does a thing like that. That's not a good look. All right, so I got a few cahoots about this, and then I just want to demonstrate Hacking Progressive, which should work. It worked right before class, so that should be good, clean fun. Somewhere I have the right browser. Here it is. I see a chat message. Let's see what it says. Can you hardwire in? No, I cannot. Yes, it's a drag. It's probably because, I can probably change it right now. We have a gap. It's probably get for not using the guest network. The guest network is by far the most stable network on campus. I should not be using the staff or student network. It's supposed to be the opposite. So as usual, yeah, we'll see what this does. Yeah, it always says that. That doesn't seem to be true. Anyway, yeah, and I do not have any way to hardwire in. Yep, anyway, so we'll carry on. This is 128, and it is chapter 6B, which is here. Okay. All right, and let's see if this share message says something. It's much better. Oh, good. Thank you for telling me. Good. So I'll just have to remember to try to use the guest network. There always seems to be something. And you have to give me feedback because I cannot see what you're doing. Now, if I was a pro, I would have a second computer here logged in as a student, but I already have more stuff that I can carry and plug in time. That's why you get amateur hour production values with my videos. At one time, I used an official college recording studio to do this, and that was, of course, 10 times worse. I forgot the cardinal rule: never use city college anything for any reason. Everything here is at a very low level of everything, and you're much better off doing it yourself. Anyway. Then they just closed it. But anyway. I'll see if I can get someplace to put the winners. That looks like that might be it. All right. All right, good. Looks like a bunch of people got in. Guest network. There we go. Good. All right. And K, that could be you. It's usually you. All right. So. And, oh my goodness, a recognizable name. I figured you might be Crazy Pigeon or something. Anyway. Now you're really out of messing with me by actually using your real name. All right. So I'll give it a few more seconds. Have to keep them guessing. All right, I guess that'll do. Okay, what does a signature prove? Doesn't prove much of anything, which is mighty strange, but that's the way it is. Now, in the Apple Play Store, a signature proves that that thing came from Apple, and that Apple checked it, and that it's not malicious, which is a whole lot more than the Google Play Store proves. Anyway, all right. So what vulnerability used two files at the same file name in the same APK file? Okay, that was called the master key vulnerability. All right, how many Android phones are encrypted? Okay, probably less than half of them. By the way, I think I mentioned this last time. About a year ago, when everybody became aware of the huge fragmentation of the Android ecosystem, Google leapt into action and stopped publishing statistics. So we can't say how many of them are old versions anymore, which is, you know, one way to look at it. But anyway, the evidence is pretty large that it continues to be a huge problem, that a large number of phones in use are in fact badly out of date. Apple just decided, you know, why do we bother compiling publishing statistics that show we're doing it wrong? Somebody realized, you know, there's no point advertising our failure. And rather than fixing it, they at least stopped talking about it. Anyway, so that shows a sign of corporate professionalism in a way. All right. So what permission level should an app use if it defines a new permission? Signature is what's recommended. Obviously, only let your company's apps use your new permission. That would be the safest thing to do. Then if it's got some kind of defect like a SQL injection or something, you've limited the harm it will do. All right. And what file lists the permissions that an app requires? Okay, that's AndroidManifest. All right, and here we go, the glorious winners. Okay, which I think is Carla. And Guest Network, I don't know who that is. And it's Caitlin, good. The usual suspects. All right, so Guest will have to tell me who they are at some point if they want their points. But the other two are repeat offenders, and I'm aware of their names, so good. All right, so I'm going to stop the recording, although not the share, and just make a separate recording because I want to demonstrate the project and people might well want to look at this as a separate video. So